Welcome you all. We'll be continuing with the next question. After the calculus derivation, we will be talking about the this projectile motion. As I repeat it, we will only derive it. We will be not discussing in detail, but with the keeping in continue this lecture series where we will discuss its whole mechanism. But here we'll be discussing only how to solve the few expressions for this projectile motion, and it is statement and definition, and then it is three important expressions: horizontal range, maximum height, and time of flight. We'll be discussing all those very things in this lecture. Now, first of all, simply, what is projectile motion? Projectile motion simply is denoted or designated or represented like this. Say it's a point O, and you throw an object in the space under the influence of gravity. When you throw an object into the space or in a space under the influence of gravity, or we can say the only force acting on the object is gravity, that very motion, and the path followed by that very object is curved, and that very motion is called projectile motion. And the phenomena of throwing the ball in the space under the influence of gravity, or the only force acting on that very object is a gravity is known as projectile. So when an object is thrown in a space and only acting force on it is a gravitational force, then the motion is projectile, and the path followed by that very object is always a parabolic path or a curved path. Every object which of its own take off from the ground and then reach to the next destination using an engine like an aeroplane, it take off from one place and reach it to the next place following this path. It cannot be taken as a projectile path, projectile motion, because here the engine is working itself. But here only force acting on the object is a gravitational force. When you जब आप ग्रेविटी के सहारे किसी ऑब्जेक्ट को फेंक देते हैं ऊपर और वो जब नीचे आ जाता है ग्रेविटी के सहारे, तो उसे हम प्रोजेक्टाइल मोशन कहते हैं. तो प्रोजेक्टाइल मोशन में आपके दो कोऑर्डिनेट्स काम कर रहे होते हैं. एक वर्टिकल कंपोनेंट काम कर रहा होता है, वर्टिकल कंपोनेंट, और एक हॉरिजॉन्टल कंपोनेंट काम कर रहा होता है. In gravitational force, you have a vertical component. Horizontal component में आप height gain कर रहे हैं, and you reach here as a maximum height h from the ground level. ये ground level है, और यहाँ से आप ऊपर जाके फिर आप वापस आते हैं on the surface of earth, और यहाँ से भी आप distance travel करते हैं. This is called range. जहाँ से object space में चला फिर वापस आ गया earth पे, and this distance is known as range, and this is a maximum height represented by capital H. And this time taken from the object from initial point to final point is known as time of flight t. How much time it takes while taking off, or when we throw the object into the space after reaching the ground level, and the time taken to complete this way distance or this way time is known as time of flight. Time of flight में हमें ऑब्जेक्ट कितने टाइम देर तक हवा में रहा और फिर अपनी जगह पे ग्राउंड लेवल पे वापस आ गया, और ज़मीनी सतह कितनी इसने ट्रैवल करी, ज़मीनी फासला कितना इसने ट्रैवल करी, दैट्स कॉल्ड रेंज. और मैक्सिमम कितना हाइट ऊपर चला गया ज़मीन से, दैट्स कॉल्ड हॉरिजॉन्टल. दिस मैक्सिमम हाइट एंड द पॉइंट the final position when we throw it in the space, and the distance from the initial position to the final position is a horizontal range. We have a three parameters, three variables in this projectile motion: horizontal range, this horizontal range, this height, maximum height, and time of flight. ये तीन चीजें आपको अभी सॉल्व करनी होती है. क्वेश्चन होता है पहला डिफाइन प्रोजेक्टाइल मोशन, आप सिंपली लिखोगे जो हमने स्टेटमेंट भी दे दी। उसके बाद आपको ये प्रूव करना होता है एक्सप्रेशन हॉरिजॉन्टल रेंज, मैक्सिमम हाइट एंड टाइम ऑफ फ्लाइट। वो आप समझ गए कि हॉरिजॉन्टल रेंज क्या है, इनिशियल जब आप जहाँ से आपने फेंका है ऑब्जेक्ट को ऊपर, फिर वापस ज़मीन पे कहाँ गिर गए, तो वो मैक्सिमम हाइट इसने मैक्सिमम डिस्टेंस ने ट्रैवल कितनी की है फ्रॉम एक पॉइंट से दूसरे पॉइंट तक, दैट इज कॉल्ड रेंज। और ये हाइट कितना ऊपर चला गया जब ये प्रोटोटाइप बना रहा था, तो हाइट कितनी लेनी, दैट इज कॉल्ड मैक्सिमम हाइट कितना चला गया, और यहाँ से लेकर यहाँ तक पहुँचने में कितना टाइम लगेगा, दैट इज कॉल्ड टाइम ऑफ फ्लाइट। अगर हम सपोज यहाँ पे जब ऑब्जेक्ट यहाँ से यहाँ की तरफ जाता है यहाँ तक, और यहाँ से वापस यहाँ तक आता है, you throw an object with a velocity, say suppose the initial velocity given to the object is u. You give a velocity u to the object and then follows a projectile parabolic path, reach it at this point. This u has two components. You have to resolve this u. It has a horizontal component u cos theta and vertical component u sin theta. The vertical component of velocity is u sin theta, goes vertically up, and the horizontal component of velocity is u cos theta. You have to remember it, the projectile motion is a two-dimensional motion, but you are using one-dimensional motion, equation of motion to solve the projectile motion. So you have to use v is equal to u plus at, s is equal to ut plus 1 by 2 at square, and v square minus u square is equal to 2as. Since we discussed that in case of projectile motion, the only acting force is gravitational force, that's acceleration is here g, the small acceleration due to gravity. So when the object is going upwards, we take g instead of a, we replace a by g because the only acting force is gravitational force. So acceleration, this acceleration is replaced by acceleration due to gravity, and when we move upwards, this g is taken as negative, and when we move downwards, g is taken as positive. So this formula will be replaced by v is equal to u minus gt, and s is equal to ut minus 1 by 2 gt square, and v square is equal to u square minus 2gs. These are the three equations of motion using to derive the projectile motion. The projectile motion में आपके पास ये तीन equation, you have to replace a by g, and you have to take in consideration that we're going upwards, your g is negative, and coming downwards, your g is positive. One more important point that you have to remember, when you go upwards up to this point, the acceleration decreases up to this half, up to maximum height, acceleration decreases. And projectile motion में acceleration top most point पे zero नहीं बनती है. When you move from the top to again on ground level, this velocity increases. Here the velocity decreases up to this point, then reach a minimum value, then velocity increase again. Go first, जब आप ऊपर जाएंगे ऑब्जेक्ट को थ्रो करेंगे ऊपर, when it reach up to the maximum height, its velocity decreases. When you reach the maximum point, its velocity is minimum, then it start again coming down under the influence of gravity, acceleration due to gravity g इसको फिर वापस ला रही है, and your velocity also again increases. अब अगर हम किसी ऑब्जेक्ट को लीनियरली ऊपर फेंकते हैं, सपोज वी थ्रो एन ऑब्जेक्ट लीनियरली, ये वहां पे टू डायमेंशन, अगर इफ वी थ्रो द ऑब्जेक्ट लीनियरली, वर्टिकल लाइन में हम ऑब्जेक्ट को ड्रॉ कर रहे हैं ऊपर वर्टिकली ऑन वाई एक्सिस पे, एक्सिस काम नहीं कर रहा है, यहाँ दोनों एक्सिस काम कर रहे हैं, एक्स एक्सिस वाई एक्सिस भी, लेकिन हम ऑब्जेक्ट को सीधे ऊपर फेंक रहे हैं, तो इस टॉप मोस्ट पॉइंट पे वेलोसिटी जीरो होगी. Because it's one dimensional motion, maximum velocity, then reaches a minimum velocity, zero velocity, then coming down to the increasing velocity, first going down up, then decreasing velocity, the velocity becomes zero, then coming down, velocity is again increasing. तो जब आप नीचे से ऊपर जा रहे हैं linear motion में, rectilinear motion में, your velocity becomes zero at the top most point, then it again starts increasing. But in case of projectile motion, when you move upwards, your velocity decreases, but is not equal to 0, but its value is minimum here, and then it again increases. So you have two components of velocity that I discussed. That's one is a u cos theta, because you resolve u, then the u sin theta. U sin theta is a vertical component of velocity, and u cos theta is a horizontal component of velocity. Now you have to remember one more thing that's very important. You have to remember that acceleration along vertical direction is always constant. While as, second point, velocity along horizontal direction is always constant. When velocity along the horizontal direction is constant, when you have a u cos theta is equal to constant, say suppose constant, so the acceleration along the horizontal direction will be equal to 0. You will have only velocity along, changing velocity along the vertical direction. Projectile motion में वर्टिकल डायरेक्शन में वेलोसिटी होती है, वो चेंज होती है, पहले चलते समय डिक्रीज होती है, फिर बाद में इंक्रीज होती है. बट हॉरिजॉन्टल डायरेक्शन में आपका सिर्फ u cos थीटा कांस्टेंट रहता है. तो वेलोसिटी remains constant along the horizontal direction, and velocity in a vertical direction changes, causing the acceleration to remain constant. But at maximum topmost point, your velocity is minimum. But g has a constant value, acceleration due to gravity has a constant value, but velocity is minimum at topmost point. So, how we can understand this? At topmost point, velocity is always, because when you move upwards, you reach a topmost point, maximum height h. For a small interval of time, you remain linear. Your direction is parallel to x-axis. And at this direction, there is no vertical component of velocity. There is only a horizontal component of velocity, that is u cos theta, which is constant. And here, vertical component of velocity becomes equal to 0. So u sin theta is equal to 0 here. At topmost point, the object even goes object upwards, upwards, upwards. Then for a small interval of time, for a small distance, it moves linearly. And linearly means parallel to x-axis, and x-axis, along the x-axis, along the horizontal direction, your velocity is constant. And along the vertical direction, your velocity becomes 0. It means in case of projectile motion, only vertical component of velocity becomes 0, horizontal component of velocity remains constant. So your u sin theta is 0 here, but u cos theta has its value. And at this very point, your u cos sin theta is decreasing, 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 and becomes 0. And then u sin theta again increases, increases, increases. But u cos theta remains constant all over the motion. U cos theta remains constant. So u cos theta is a horizontal component of velocity, and u sin theta is a vertical component of velocity. U sin theta varies vertically, whereas u cos theta remains horizontally constant. Now,